Okay, so we have a 5 amp circuit breaker at A. When the switch is open, what is the current at A? Well, when the switch is open, this middle branch here doesn't exist. No current flows through that. So if the switch is open, this is a very simple circuit where you got your EMF and then just the combined resistor R124, where R124 is R1 plus R2 plus R4 because they're in series. So that's 21 ohms. Okay, and then the current in this case would be the voltage, which is 24 volts divided by 21 ohms. So that's 1.1 amps. Okay, so there's part A. Now, part B. When the switch is closed, what happens to the total power, or what happens to the circuit breaker? So again, we need to find the current passing through A when the switch is closed. All right, well, when the switch is closed, it's still the case that R1 and R2 and R4 are connected in series, but that branch also has a parallel component to it. So let's redraw this. When the switch is closed, we've got a resistor here that is R3, but then we also have another resistor up here, which is R124. Okay, and all right, so the current, the voltage drop across both. The voltage drop across resistor 124 and the voltage drop across resistor 3 is 24 volts, right? Because they're in parallel. And the current passing through 124 is still 1.1 amps. Really nothing's changed about that branch. But now the current through resistor 3, that's another story. The voltage difference is 24, the resistance is 5, so I guess that's 4.8 amps, right? And then the total current then, I total, is equal to I3 plus I124. That's the junction rule. And that adds up to 5.9 amps, which is greater than 5, and so the circuit breaks. Okay, another way to do this would be, you could also consider R3 and R124 as a single resistor, R total. Right, where R total, 1 over R total, is equal to 1 over 21 plus 1 over 5, and therefore R total is 4.04, and I total is 24 over R total, which is 5.9 amps. So either way, the circuit breaks. Okay, now for part C, when the switch is closed, does the total power dissipated by the resistor R2 increase, decrease, or remain the same? Well, with S closed, the current I124 through this branch here is the same as with the switch open, right? It's the same as with the switch open. We already deduced that, right? When the switch was open, we got 1.1 amps, and when the switch was closed, we got 1.1 amps. And the resistance, R2, is the same, and therefore power dissipated by resistor 2 should be the same.